And then the last concept we're going to look at is A. So we know about P, we know about Q, but what about A? A basically describes the stretching of the function. So we look at the basic x squared again. We're going to look at the basic x squared again. Okay? We're going to look at x squared, and then we're going to compare it with 3x squared, and then we're going to compare it with half x squared. So when we plot these values, let's say we plot in, so instead of calling it f of x, we know that functions can have different names, right? Let's call it g of x. Maybe we can call this h of x. So when we plot in the same value, so f2, then this would be g2, and this would be h2. What do you get? So this would be 4. This would be 3 times 4, so 12. And this would be 2. Correct? Because you just have to times 3 of f2 f of x, and this will be divide 2 of f of x. When you draw a function, so this would be your typical, no, okay, something like this. So we take this to be the, let's take this part over here to be 2, alright? So over here will be 2, and over here is 4. So for g of x, it will be higher, right? So for g of x, it will look higher. So okay, perhaps I should have used black for that, but whatever. So for g of x, it will be higher. So let's just put this. It will be higher. So this will be 12. And notice how when we put it higher, it becomes narrower. So it becomes so narrow that you want to draw an absolute function. Look at that. It becomes narrower. See, by putting it, when we increase the value of a, it becomes higher. Because for the same value of x, it's a higher value, so it actually becomes narrower. But now let's say the coefficient of a becomes lower, so a becomes lower, the value would be lower, also lower. So it will be, let's say over at 2, trying to find it to be here, 2. And this is where you realize the function becomes broader. So you see, if you want to bend it like this, so pretty bad bend. If you want to bend it like this, it becomes broader. Alright? So we know that when a is more than 1, it becomes narrower. And we know that when a is less than 1 or more than 0, it becomes broader. Now what if it goes below? Broader. What if it goes below 0? The same rules apply, but just strictly look at the positive value. So let's say we have a negative value. Everything will just be flipped, but the same rules will apply. Broader, narrow, everything. So a minus x squared minus 3x squared minus half x squared will literally just be the exact same thing that we just did, but everything will be flipped upside down. So that is why a controls the shape. That is why we say a defines the shape. A defines the shape because you control those values, it becomes broader, narrower, or you might even flip. And just remember, If it's a positive, it's happy, you know, you're positive, you're smiling. And if it's negative, it's downwards. It's negative, it's feeling bad feelings, it's going down. So that's why we have positive A, we have negative A. And then P and Q are the coordinates of the vertex. Just remember to zero it. Remember I taught you all the zeroing. I taught you guys how to zero it. That's how you can make sense of finding the maximum point and the minimum point. Thank you. In the next video, we'll be going through more about the quadratic function.